Today we learned the chapter 6b, integration, application problems. First of all, we talk about the formula. Some formula we already used in A, 6a part. So like constant, take integral will ku du will ku plus c. And power rule, integral u to the power n equals u to the power n plus 1 over n plus 1 plus c. You can take derivative on this. And n plus 1 cancel. Then minus 1 get u to the power n, because antiderivative integration is antiderivative. Like this scalar constant multiply rule, the scale k factor out integral. Like this sum or difference rule, the sum of functions take integral equal to each function take integral and the sum or difference. E take derivative is still E, so take integral is still E. Ln absolute u take derivative is 1 over u, so integral 1 over u is ln u, take absolute value plus c. And this is what we call fundamental theorem of calculus. Integral f of x take integral is f of b minus f of a. What is f? This integral f of x dx is equals f of x. So f of b is equal 0 to b f of x dx. F of a is integral 0 to a f of x dx. Then subtraction, you got f of b minus f of a is equals the two subtraction. Because integral integral 0 to b f of x minus integral 0 to a f of x dx. And this one is equal integral 0 to b plus integral a to 0, negative, plus negative 0 to a f of x dx is equal integral 0 to b f of x dx plus this negative is equal 0, a to 0 f of x dx. So the two together from a to 0, then 0 to b, that's equal to a to b f of x dx. So integral a to b f of x dx equal f of b minus f of a. Average value is integral f of x dx divided by b minus a. Now I need to talk about some concept. There's two kinds. The first one is antiderivative. A number take integral, then you take derivative, is still itself. A number take derivative and then take integral is still itself, antiderivative. That's one kind of concept. Second concept for the integration is area under the curve. That's use the Riemann sum. Riemann sum. Riemann sum. Use this as a concept like this. F of x. If a curve like this, and then you go partition into equal parts, subintervals. Partition into subintervals. Like this is 0 if this is x1, x2, x3 until xn. And then here if I say this is xi, and then for this this we call they are equal. Those are equal. Those are equal intervals from like if here is from A to B. If I say this is A, this is the B, this is the B, and between A and the B, you divide it by n intervals. Each interval we call delta x. So this from A to B, and this is A point, this is the last one, this is B, and you divide it into subintervals, x1, x2, x3 until here xi until xn. Then area of first interval is going to be, if I use midpoint, it's going to be this one. If this is a midpoint, or use right side point, either one. Or, and the area on this interval will be right side point. It's going to be this area. And since the base is delta x, and this point, this is f of x1, and this height is f of x2. So it's going to be f of x1 times the base. This is rectangle area. Add this f of x2 times the base, also delta x, because we divided equal intervals. Then plus this is going to be the height is f of x3 and times the base, that area, f of x3 times delta x. And the plus until the last one, or the middle one, we call f of anyone xi times delta x, and plus until the last one is f of xn times delta x. And that's the sum. And you can put down as a summation f of xi times delta x. I go from 1 to n. And those are the area under the curve. Now if we take the limit, this one take limit, n go infinite. That means this delta x become very, very small. So if you take limit when n go infinite, when limit n go infinite, that difference of this x is very small. We use dx represent dx. So the base times the height. This become dx base. What is the height? Become a function. This a, this is b, and this is a function, and become this. Its height is f of x. The base is dx, and that's the area of this rectangle. And then you add so many area of the height times the base. And they are very close to each other. Very, very slim. So this becomes f of x height times the base is area of rectangle. And so many add together, so many sum. This we call discrete sum. And I go from 1, 2, 3 until n. That's we call discrete sum. After you take limits, n go infinite and become continuous number, continuous sum. This we call continuous sum. Add together is continuous sum from A to B. So this symbol become this. And that's the area under, that's become, and this we call continuous sum. This is when n go infinite. Then this discrete sum become this symbol, this part becomes symbol, continuous sum, A to B. And this is the area under the curve. That is the area under the curve. When n go infinite, become continuous sum. That's integral. So this is the height. This times the base is area of the rectangle. So many rectangle add together. That's integral. That is the area under the curve. Area under the curve. This we call Riemann sum. Use Riemann sum to explain the integration. And so f of b, here this f of b is from started as 0 to b area. Minus f of a is minus this area from 0 to a. And then that is the area between a and the b. That is a fundamental theorem of calculus. Average value is this area. You can see for each x, they have a different f of a different value, and we want for each x have the same value. We call average value. Same value, average value. So this area under the curve, this area, if you divide it by the base, b minus a, base b minus a, then you can find out a constant number. You can find a number. And you will get that constant value. This value is the average constant for each x have the same height. Each x have same height. This is the average times the base equal this area under the curve area. So that's the average value meaning. Average value times the base b minus a is this red area, rectangle area. This area is equal to the area under the curve. So you can see the average value. You do under the curve area divided by base divided by b minus a. This is the area. Under the curve area is a to b f of x dx, and you divide it by b minus a is average. Then average times b minus a is under the curve area. So under the curve area is equal to b minus a base times an average is equal to this rectangle area. You always can find out. Average means for every x have the same height. Same value. Same height. Original for function for every x is different height. Different function value. but average means for every x have the same height. That's, in other words, this rectangle area equal to the area under the curve. So average value, you got this is the average. Average times the base, the height times the base is going to be rectangle area equal to this under the curve area. That's the basic the concepts. And the area between two curves is come from Riemann sum. I just talk about this Riemann sum. Under the curve, use a Riemann sum. Then those rectangle area add together. Rectangle area f of x times the base delta x, and so many n of it. When n go infinite, then become this height times this base dx, become f of x times dx, this rectangle area. Add this rectangle, add this, so many add together. So become, when n go infinite, become function f of x, that's the height, and times the base, very small base, very, very little dx. That's a rectangle area, and continue sum, add together. This, when n go infinite, become this continuous sum. That's area under the curve. And if a two curve, so this function talk about area between two curve. Two curve, it's x, and one curve is f of x. Another curve like g of x. And then from A to B, an area between two curves. So first of all, you go area A to B, f of x dx. That's area on the f function, this one, this area. And then you minus integral A to B, g of x dx. That's area under the function g of x function. So you subtract. So you do this function, subtract this function. That's going to be the function between two curves. Become the function between two curves. So is this under f function is this area, and minus area under g of x under g, and that's equal to, and according the properties, you can take integral A to B, f of x minus g of x dx, this subtraction. So if an area between two curves, and you do the two function subtractions and take integral. Then consumer surplus and producer surplus. It's consumer function is a decreasing function. Producer supply function. Producer supply function is the increasing function. This and this is x, how many units, x units, and this is p, the price per units. And started with for the consumer cost function. This is the cost function. This is a p of c of x is a cost function. The cost function is a decreasing function, started at high price, and each when x units increased, the price decreased. When units increase in price, consumer, and then the supply function is increasing function. This is S of x. Supply function is increase function. When the units increased, the price increased. And they have this is a demand function. Demand function. I'm sorry, it's demand function d of x. And this is going d equals supply function s of x. Then they have a intersection point, and this intersection points we call equilibrium points, which is units how many units we call equilibrium quantity and the equilibrium price. Use bar, x bar, p bar represent. So at this point, this is the x bar, and at this point, it's a p bar. And if this is if the market price is at equilibrium points, equilibrium price as a market price. If a market price is, we assume is this. So in the market, actually the money will be x bar, how many units, and each unit is a p bar. Unit price is p bar timed together. So that's the market. You can say the market money in the market. Then for the this is for the consumer demand function. Then over, this is the curve, and under the curve, the price for demand, the price for the this is a demand function, and times the dx. So for this d of x price times dx, you take integral. That is going to be for the consumer, we assume can earn so much money, but actually in market is so much money, so you minus p bar x bar, and this is over. This part is over, and that's called consumer surplus, which is this green one. So the consumer surplus is integral from here, from 0 under this curve, demand function, from 0 to x bar. Dx from 0 to x bar under the curve. Suppose so much money. Then you minus p bar x bar. And actual one is in market, actual one is this. And this part is we call consumer surplus. Consumer surplus, so which is this one. And producer surplus. Producer surplus is low. And then we assume and this function, this one in market is market price is p bar, and sell out x bar units. So is p bar minus times x bar. So it's in the market is so much money, and minus under it, this part, under this supply. With supply, producer assume can supply so much. So is so much is the price times price is this S of x times dx. And then so many add together, continuous sum. And from 0 to x bar. So you do this part, this area, so much money in the market, as soon as so much money, and minus for supply. The supply only available is this area, money is this area, and subtraction, that is called a producer surplus. This area, producer surplus, PS. That's a producer surplus. Then next one we call next formula is accumulated. Accumulated future value of an income stream. Accumulated, also called future value of an income stream. Income stream means constantly have an income. If the rate R of t is per year income is R of t, and deposit this rate per year income is R of t rate, and then deposit into the like for the bank or account, and earn interest compounded continuously, and per year you deposit same amount, certain money, like R of t is different money, different amount of money changed by time t, and the formula is going to be this. Now how we get this formula? Here, right over here, this one. Future accumulated value of an income stream is this formula. Here is a proof. R of t is the rate of income generation at any time t in dollars per year. The smaller r is interest rate compounded continuously. T is compounded continuously for total how many years? And the time interval is go from 0 to t, so capital T, so many years is a continuous compounded. It's partitioned from 0 to t. It's partitioned into n sub-intervals, t1, t2, t3, t4 until ti minus 1, ti until tn minus 2, n minus 1 until tn. Tn is equal t, which is total is t, capital T, from 0 to t is capital T. Total how many years, and divided by n intervals, and that is the base. This is a delta t, and denote the right end points of this intervals by, this is right end points, this is left, this is end right, denoted by t1, t2, t3 until tn. Tn is t. So we partition into n intervals. If this curve it's R of t, it's the rate per year. Now, for example, if you per year you deposit R of t dollars at t1, R of t1, and times this interval delta t, how many years, like a half year or quarter years? So that's the rate. So tying together is during this half year or during 1 year. For example, like during 1 year you deposit so many dollars, then you will totally deposit how many dollars that means. And next, compounded continuously. Accumulate amount at end of t years. Accumulate amount at end of t years is this formula. That's what we learned before. P is the principal. R is the annual interest rate compounded continuously. T is how many years. The formula, after if you deposit into the account for P dollars compounded continuously at the interest rate, annual interest rate is R. Then after T years, the amount after T years is equal amount is the A equal P principal times e to the power RT. This is the compounded continuously interest rate accumulated value. Amount is formula is this. And for this question, and for this interval, you deposit R of Ti times delta T. Here, principal is R of Ti times delta T is put in this P. At this period of time, this is the after up to T years, capital T, from small ti to capital T, total capital T minus Ti years, and plug into this formula in this T. Interest rate is R. So principal so much after to the end of capital T years. T minus Ti, total compounded T, capital T minus Ti compounded time, so many years. Principal is so much at time Ti, because this is the rate. Delta T is total deposit, how much dollars. Principal is principal. Use this formula. So this at time Ti, the future value after up to T, from Ti to capital T, between it is capital T minus Ti years. So compounded so many years. So this T is put in capital T minus Ti. R is the interest rate. Principal is this. And this is the amount for at time Ti. The compounded amount up to capital T. And then add together, there's n intervals. So summation I go from 1 to n AI is the summation I go 1 to n. AI is this one, and put it here, summation this one. That's the discrete sum, amount, future value accumulated, compounded continuously. And go continuous sum, which is take limits, amount equal limit, n go infinite. So that means this delta T become very, very small. Become this curve, continuous curve, instead of n intervals, become very, very small. So when n go infinite, I go from 1 to n summation. This part become integral 0 to T, capital T. So this part become integral 0 to capital T. This R of Ti become R of T. e to the power r capital T minus t, this ti replaced by t. And this delta t, when n go infinite, this smaller interval, delta t, become very, very small. We call dt, difference between the time, and very, very small, little, dt, become dt. So formula become this. And then integral 0 to t r of t. This e to the power distributed in rt, and the minus rt, r small t, and separate become, because the two add together, the same base is e, the two add together go back this. So this you go become this. This one, e to the power rt minus rt, which is separate, become e to the power rt times e to the power negative rt. Because the two add together is go back this. So separate become this. And so since this one is a constant, it doesn't change with smaller t, lowercase t. So you can factor out. This one factor out, go from. This one go from. So you got e to the power r capital T integral 0 to t remain this r of t, e to the power negative rt dt. That's the formula. Future value formula. This future value of an income stream formula. And we got proved amount equal e to the power rt, this formula. And second one, what is a present value of an income stream? This is the formula. So because the future value is equals e to the power rt, this e to the power rt integral 0 to t r of t e to the power negative rt dt, then equal present value times e to the power, this is what we call compounded, compounded, and figure out total amount, how much deposit in, times e to the power r for capital T years, compounded continuously for capital T years. Use this compounded continuous formula. Amount is this future value. This one future value is this, equal to principal, we call present value, times e to the power rt for capital T years. Then principal, which is present value, equal e to the power r capital T, equal to future value is this, accumulated is this. Then cancel e to the power rt. So you got present value equal this part. So present value equal this. So for you can see in this formula sheet, the formula sheet, this is accumulated, compounded continuously if a deposit rate is r of t. This is future value. And actually this part is the present value. Present value is this part, principal, times e to the power rt, its amount. So next one, now if r of t is a fixed, a constant, r of t doesn't change with the time, it's constant, and we call amount of an annuity, and this formula, where m is the number of turns per year, p is the principal per turn deposit, you deposit per term deposit same amount. Then that means the R of t become, if you deposit principal per term is P dollars, and per year you have M terms. For example, if you have 4 quarters per year, M equal 4. Each quarter deposit $100, then 4 times 100 is the total amount per year you deposit in. So it's MP. MP is the total amount per years. And that's put into the future value. This one. R of t become MP, which is this. R of t. This is a change with t, but this is it's not. If R of t equal MP, then e to the power RT, this RT factor out, MP factor out, and only remain this. This become R of t is MP. And then here MP is fixed, so doesn't change with t, so factor out MP. E to the power RT, integral 0 to t, e to the power negative RT. And so this take integral. So it become MP times e to the power RT, this take integral. Is e take integral still TE to the power negative RT divided by negative R. And then t go from 0 to capital T. Then equals MP e to the power RT. This negative R, I factor out R. Remain negative e to the power negative RT. T go from 0 to capital T. Then this put over equal this. Then this capital T plug in. You got negative e to the power negative R capital T minus negative e to the power negative times t is 0 plug in. So copy this, done. Then this negative e to the power negative RT, this negative become plus 1. And then you do this multiply in. E to the power RT times negative e to the power RT add together is e to the power 0. It's a negative e to the power 0. It's 1, so it's a negative 1. Then this times in is e to the power RT minus 1. And that's get this formula. Let's get proved formula. Then what is the present value, which is this formula equal to amount equal present value principal times e to the power R capital T. So the future value is here MP over R e to the power R capital T minus 1 equal present value times e to the power RT. Principal times e to the power R capital T years. And then divided by e to the power R, both sides cancel, so this divided done. Then you got MP over R. This e to the power RT divided by e to the power RT, it's a 1. Minus 1 over e to the power RT is e to the power negative RT. So this is a present value. So if you want to try to understand how we get those formulas, you can look at here proof. prove the following on your notes. Prove 1, future value, 2, present value, 3, if the rate is deposit in is constant, we call amount of an annuity. The 4 is present value. The 4 formulas is a proof over there. 1, 2, 3, 4.